Did you know that a lot of California grapes travel around the world on massive cargo ships to other countries? Have you ever thought about how heavy cargo ships float when at the same time their anchors sink? Cargo ships are literally tons of steel floating the open waves. No problem. But anchors? 1,000 times lighter, plunge to the bottom. Discover why this happens from a dynamic demo from some real groovy dancers. The California Raisins school us with bobbin and bouncing experimentation for all of us to try out. First, let's prep our lab. The hard part? You'll have to part with a box of raisins. A bowl, a glass, or that perfect see-through container for putting on a showstopper. Carbonated water like club soda, tonic water. Keep it clear, no sugary drinks. Step 1, fill your container with carbonated water. Step 2, grab a handful of raisins and drop them in. And it's Cirque du Sun-made. Ladies and gentlemen, the California Raisin Water Dance. A descending disco, if you will. Oh, some serious dipping. Breathtaking bubbling brewing at the bottom. Ooh, and look how they mix it up. How do they do this? How is this related to our cargo ships? Well, raising the question of how is it that the raisin both float like a cargo ship and then suddenly behave like anchors? The simple principle to understand is buoyancy. Buoyancy. Yeah, like a buoy on the open sea, it's buoyant. And when we look deeper into the science, our raisins at first drop like an anchor because they are not buoyant. But you see, they get a little help from their friends, bubbles. They get attached to our raisin's groovy outerwear, making the raisin larger and suddenly buoyant. So yeah, floating is what happens when we see this. But the question really is, why does this happen? A deeper principle surfaces.
Density.
Density is basically the raisin's mass related to its weight, or how big something is related to how heavy it is. Let's pretend that 2 boxes of grapes were accidentally left on the cargo ship deck when loading up. One is almost empty because someone opened one box and ate a whole bunch for lunch. And the other is still full. Your cargo ship hits an enormous wave, and both boxes fall into the ocean. But only the almost empty box of grapes floats, and the other full box sinks. Well, the simple answer here, floating box floats because it's lighter, right? Wait, no, because why does the steel cargo ship float that's 1,000 times heavier than its lighter steel anchor? Density is at play. The box full of grapes is more dense than the near-empty grape box. So it's not about weight, rather a relationship between the box and the water, called displacement. Basically, it's an issue of how much water is displaced that determines if we sink or swim. Science says density equals mass divided by volume. In case of our uplifting dance partners, the bubbles attach and change the volume of our raisin. Nice move. The bubbles increase the volume of the raisin substantially, but contributes very little to its mass. As a result, the overall density of the raisin is lowered, causing it to be carried upward by the more dense fluid surrounding it. Archimedes' principle states that the buoyant force exerted on a fluid is equal to the weight of the fluid displaced. Since the raisins now have a greater volume, they displace more water, causing the fluid to exert a greater buoyant force. The buoyant force of the surrounding fluid is what pushes the raisins to the top. Buoyant force! Okay, that's a great name for a band, right? Anyone?